The next topic in this statistics, which is going to be started, is the line graphs. So the points to remember and understand are: number one, a line graph is another way to represent data. A line graph is drawn by plotting the points corresponding to the data and then joining the points by the line segment. Second point is, we usually use a line graph to represent a set of the data that varies with time. So this is usually, not specially. The last point is, the advantage of using a line graph to represent data is to be able to spot the trends of the movement of the data. A line graph can also be used to forecast future data values. So this is the advantage of the line graph. Now we are going to solve a question that will make our concepts more clear. So the table shows the temperature of a boy having a fever taken every hour starting from 8 a.m. Draw a line graph to represent the data. So here is the data that is starting from 8 to 1 o'clock. And temperatures are given. So first requirement is draw a line graph. So remember, always a temperature is always will be we will always plot the temperature on the vertical line, and time, that is actually independent quantity is always drawn on the horizontal line. So here time is actually starting from 8 a.m. till 1 p.m. So first we will draw the vertical line and the horizontal line. So actually time are actually starting not from 1, 0 and 8 are away from each other, so we have to draw the zigzag line. This is the mistake in this graph. So draw a zigzag line over here like this, because temperatures are also starting from 37, which is also away. So this is done by the graph, but here not zigzag line is given, so draw the zigzag line over here. So time is starting from 8 a.m. till 1 p.m. So here is 8, then 9, 10, 11, 12, and 1. And temperature are actually from 37 to 40. So 37, 38, 39, 40. So look carefully between these two values. There are 10 small boxes. It means one small box will represent 0.5 degree, that is temperature. And here we have 8 to 9, 9 to 10. There are also 10 boxes. So 10 boxes are representing 60 minutes, because 1 hour is of 60 minutes. So one small box will represent 6 minutes. So these are the things which should be in your mind first, because the requirements are now, okay, at 8 a.m. 38. So 8 and 38 values will be plotted first. So here is 8 and here is 38. First point is plotted. Then 9 and 39. So here is 9 and here is 39. This point is plotted. Then 10, 38.5. Here is 10 and here is 38.5. So this point is plotted. Next is 11 and 39.5. So here is 11 and here is 39.5. So next is 12 and 38. So here is 12 and here is 38. Next, last one is 1 and 37.5. So here is 1 and here is 37.5. So one small box will represent 0.05. So be very careful. The next requirement is the time when his temperature was the highest. And from the graph we can see this is the point which is having the highest temperature, and the time then is 11 a.m. So the time is 11 a.m. having the highest temperature. Okay, next requirement is an estimate of the temperature at 8:30. So first we will locate 8:30. So 8 and 9 in between 8:30 up, that is here exactly at the center of these 2 points. So we will draw a line with the help of scale touching the graph, and from there to the temperature, that is 38.5. because this is 38, this is 39, exactly between that is 38.5. Last requirement is the time when the temperature is 37.8. So this is 37.8 because this is 37, this is 37.1, 2, 3, 4, 5, 6, 7, and 8, 37.8. So with the help of scale, we will draw a line touching the graph, and from there we'll find the temperature. So we'll know the time. So that is the 12:24. So like this, because we have at the beginning calculated that one small box is representing 6 minutes, so this is 12, so 6, 12, 18, and 24, so this is the time 12:24. So this is the solution. The statement of the question is the line graph shows the number of the students who enrolled in an advanced mathematics course over a period of 7 years. So this is a line graph given for 7 years for a particular course. A part is in which year was the enrollment the greatest. So we can see from the line graph, this is the maximum point on the line graph, and this is actually of 2005. So 2005 is the year. Between which year was there the greatest increase in the enrollment? So we can see from here to here there is a sharp increase. So this is from 2002 to 2003. So this is the maximum increase. C part is in which year was there a decrease in the number of the enrollment? From the graph we can see this is the year from in which the enrollment is decreased, and this is 2006 year. Last part is find the percentage increase in the enrollment from 2003 to 2004. Give your answer correct to the nearest percent. So 2003 is here, that is 290, and 2004 is here, that is 360. So 360 minus 290 divided by 290 multiplied by 100%. So now solve it on the calculator. So 360 minus 290 equals 70 divided by 290 multiplied by 100. So the answer is 24, because the requirement is give your answer correct to the nearest percent. So the answer will be 24%. The statement of the question is the line graph shows the number of the cars purchased and the rented from a company over a period of the 8 months. So there are two line graphs drawn on the same graph paper. The unbroken line is representing number of the cars purchased, and broken line representing the number of the cars rented. So here is the line graph. So now the requirement is in which month was the least number of the cars purchased. So unbroken line is cars purchased. So here is the point. So this is actually the month of February in which most of the cars purchased. So February is the month. B part is in which month was the difference between the number of the cars purchased to the number of the cars rented the greatest, and find the difference. So the month, here is the difference, here is the difference, this is the same, this is the difference, this is the difference, and this is the month in which the cars rented and purchased are the highest difference, that is June. So the next requirement in the same part is find the difference. So the cars rented are 36 and purchased are 11. So this will be equal to 25. How many more cars were rented than purchased in the period of the 8 months? So first we have to find the rented, then purchased cars, and finally the total one will be find it out. So this is 30 plus 40. This is purchased cars, 30 plus 40 plus 31, 2, 3, so 33. Next is 24, then 22, then 11. 24, 22, 11. Then 16, then 25. Now rent is 25 plus 35 plus 31 to 3, 33, then 29, 33, 29, then 27 plus 36, 27 plus 36 plus 29 plus 32. Now solve it on the calculator. This will give the 25 plus 35 plus 33 plus 29, 27, 36 plus 29 plus 32. That is equal to 246. Now this one, 30 plus 40, 70, 103, 103 plus 24 plus 22 plus 11 plus 16 plus 25, that is equal to 201. And the required difference is how many more cars were rented than purchased in the period of the 8 months. So the difference will be equal to 45. The next requirement is the number of the cars purchased and rented was the same in which month. So this is the point at which the purchased and rented cars are same, and this is the month of March. Final requirement is find the ratio of the number of the cars purchased to the number of the cars rented in February. So in February, cars purchased are 40 and rented are 35. So 40 ratio 35, that will be equal to 5 8s are 40 and 5 7s are 35. So 8 ratio 7. The statement of the question is the hourly temperature of a patient in a hospital ward is shown in the line graph below. Find the highest temperature recorded. So the highest temperature definitely should be here. And if you see from here to here, 39 to 40, so total 10 boxes are in between there. So this is definitely 39.5 and this will be 39.6. So this is the temperature which is actually 39.6. So 39.6 is the at which find the highest. So 39.6 is the answer. This is the highest temperature. Okay, B part is at which period did the temperature increase most rapidly? So if we see, here is actually 2, 5, 7, and 8 boxes are covered here. So here are 1, 2, 3, and 5, 8, and 9 boxes are here. So this is the time period during which the increase in the temperature is most rapidly. So that is actually from 12 and 13. So 12 and 13 is the time during which temperature rise most rapidly. So this is the answer of first part. Second is decrease most rapidly. So this is easy question because you can see this is the period during which temperature decrease most rapidly, and this is actually time between 13 and 14. So 13 and 14 hours is the time during which temperature decrease most rapidly. Okay, C part is estimate the patient's temperature at 9:36. So this is somewhat difficult because here is the time given, and 8 and 9. So 1 hour is representing by 5 boxes. 1 hour is equal to 60 minutes, and 60 minutes are representing by 5 boxes. So 60 divided by 5 is equal to 12. It means one small box will represent 12 minutes. So the requirement is 9:36. So here is 9 o'clock. So 12 minutes, 24 minutes, and 36 minutes. So this is the time 9:36. So this is the temperature. So here we can calculate now 38. 0.1, 0.2, 0.3, 0.4. So 38.4 is the 38.4 degree is the temperature at 9:36. And now 12:48. So here is 12 o'clock. So 12 minutes, 24 minutes, 36 minutes, and 48 minutes. So this is the time 12:48. You people should use scale because I'm holding a lot of things. So that's why this is problem for me to use the scale. So this is the temperature, that is 39.1, 0.2, 0.3, 0.4. So 39.4 is the temperature at 12:48. The statement of the question is the line graph shows the maximum and the minimum temperature degree C in Osaka over a period of a week, and the key is unbroken line represents maximum temperature. So this is the graph for maximum, and broken line represent minimum temperature. So this broken line represent minimum temperature during a week period. So requirement is when was the highest maximum temperature recorded in that week. So maximum temperature can be seen this. So this is requirement when was. So when was it? Was on Wednesday. So the answer is Wednesday. Okay, next requirement is find the temperature difference on Monday. So Monday. Okay, now the temperature difference is the requirement, and you can see 10 small boxes are representing by 5 values. So one small box will represent 0.5 because 0.5, 1, 1.5, 2, 2.5. So this is the pattern. So the requirement is find the temperature difference on Monday. So on Monday, here is 2.5. So this will be 3.5. So 3.5 minus minimum temperature is, this should be, sorry, this is 7.5 and this will be 8. So 8 minus, this will be 2.5 and this will be 3. So 8 minus 3 is 5 degree is the temperature difference on Monday. Next requirement is Wednesday. So here is Wednesday and this is the temperature, that is maximum. So this is actually 12.5 and the one small box below it will be 12. So 12 is the maximum and the minimum is, here is 7.5, this will be 8 and this is 8.5. So 8.5 and the difference will be 3.5 degree. So this is the temperature difference on Wednesday. Okay, C part is, on which day was the temperature difference the smallest? From the graph we can see the difference between these 2 points is the smallest and this is actually on Saturday. So Saturday is the day on which the temperature difference was the smallest. Next requirement is the greatest, and here we can see this is looking greatest and this is looking greatest. So we count, so 1 2 3 4 and 5 9 and 10. So this is the 10 box difference and here is 5 and 5 10 and 11. So these are 11 boxes. So Sunday is the day on which the temperature difference is the maximum. So this is the answer. Statement of the question is, the table below shows the hourly temperature of a patient in a hospital ward on a certain day. So 7 o'clock 38 degree, 8 o'clock 39 degree and up to so on. Draw a line graph to show this information. So first we have to draw the line graph. So we are drawing the line graph here now. Because the values are starting from 7 and this is starting from 38, so we have to zigzag the path here. So this is the zigzag. So from here the temperature starting is 7 8 9 10 11 12. So we have to mention the temperature. So this is 7 8 9 10 11 and temperatures are from 38 to 40 degree. So suppose this is 38, this is 39, this is 40, and now we will plot the values 38 and 7. So this is the first point. Next is 39 8, 8 and 39 is here. Next is 9 and 39.5. So here is 9 and 39.5 should be between the two small boxes. Next is 10 and 39.5. So 10 and 39.5 will be at the same level because temperature is same. Then 11 and 40. So here is 11 and here is 40. And then 12 and 38.5. So here is 12 and 38.5. So here is 38.5. And now we will join these dots with the help of the scale. So here is the line graph. B part's requirement is what was the highest temperature taken during that period. So from the graph, we can see the highest temperature is this one. That is actually 40 degree. So here is temperature. Here is time. So the temperature is 40 degree. C. Next part is at which period did the temperature increase most rapidly? So from here we can see this is the time during which temperature increase the highest, because this is covering almost 10.5 small boxes, but here are lesser than this. So 7 to 8 hours is the time. Is the time during which the temperature increase most rapidly. Last part is estimate the patient's temperature at 10:36. So from graph you can see 10 small boxes are representing by 1 hour, and 1 hour is actually having 60 minutes. So 60 divided by 10, it means one small box will represent 6 minutes. So the requirement is 10:36. So 10:36, so this is 10, and this center line will represent 10:30, and this is the point 10:36. So at this time we have to calculate the temperature. So this is the time actually, and we are going to calculate the temperature at this time. This point will represent 39.5. So 39.55. So 39.5 and 39.6. So 39.6 is the temperature, because one small box will represent 0.1 degree. So 39.6 is the temperature. So this is the answer. The statement of the question is, the table below shows the profits of a company from 2001 to 2006. So here is the table. First part is draw a line graph to represent this information. So the profits are in thousands dollars, and the years are from 2001 to 2006. So we have to draw the line graph of this data. So we are going to draw the line graph. So this is the vertical line, and here is the horizontal line. Profits are actually starting from the minimum value is 82.7 or 81.2 is the minimum, and years are starting from 2001. So 81 to 85, 6, 81 to, so 82, 86. So we have to draw a zigzag line, because profits, we are starting values from 80. Here is 0. So this is 80, 81, 82, 83, 84, 85, 86. So up to 86 we have drawn values, and 2001 to 2006. So again, draw a zigzag line from here. So 2001, 2002, 2003, 2004, 2005, and 2006. So now plot the values. First is 2001 and 80.7. So here is 2001. This is 80.567. So this is the first point. The next is 2002, 81.2. 81.2. So this is 81 and 1 and 2. So this is the 81.2 value. Next is 82.7. So 82, this is 5, 6, 7. This is 82.7. The next is 83.3. So this is 83, 1, 2, 3. So this is 83.3. The next one is 84.5. So 84.5 is here. And the last one is 85.2. So 85.2. So here is 85, 1 and 2. So these are the points which are going to be joined now. So these 2 points will be joined first, then these 2 points, then these 2 points, then these, the next 2, and finally the last 2. So this is the line graph of the question. Next requirement is find the percentage increase in the profits from 2002 to 2003. So this can be find it out from here. So from 2002 to 2003. So B's first part, as you know, 2002 to 2003. So here is 2002, here is 2003. So 82.7 minus 81.2 divided by the original value, that is 81.2, and multiplied by 100% will give us the answer. So solve it on the calculator now. 87.2 minus 81.2 equal divided by 81.2 multiplied by 100. So 7.39% is the answer. Okay, B's second part is from 2005 to 6. Likewise, 2005 and 6, so 85.2 minus 84.5 divided by 84.5 multiplied by 100% will give us the answer. So solve it on the calculator. 85.2 minus 84.5 equal divided by 84.5 multiplied by 100. So answer is 0.828. 0.828% is the answer. Last requirement is estimate the profits of the company in 2008. So we have to estimate from the graph now in 2008. So first we will check the year 2008. So here is the year 2008. And now we will draw the line of the best fit. The line of the best fit is actually the line passing through the maximum of the points. So this is the line of the best fit. Almost 2008 is here. So from here we can see this is 2008. This is 2008 here. And from here we can see the profit is almost This is almost 86.567, 86.7. So 86.7 is the estimated profit in 2008.